Hello everyone, welcome to Mechanical Engineering Design and Innovation course. Myself Dr. P. Rajkumar, Assistant Professor, Department of Mechanical Engineering. So the topic for today's discussion is Conceptual, Embodiment and Detailed Design. The aim of the present session is to make you to understand the concept of conceptual, embodiment and detailed design. At the end you will be able to say what do you mean by conceptual design, what do you mean by embodiment design, what do you mean by detailed design, and what are the parameters involved in each design step. So let's start the session. So we already know that the engineering design process or any new product design process involves or it starts with the product definition. That means what is the requirement of that product, why I am designing or why I am creating that product. So that means all the design products should or will start with the definition of the product. Once the definition of the product is clear, then based on the definition we will create new concepts, different concepts based on the definition of the problem. Then after creating different concepts, for that concepts we will add some configurations and architectures and some parameters, so that we will get the next level of the design. That we will do the adding the architecture, the parameters, the configurations, everything we will do in the embodiment design. Once for that design all these parameters are added, then in the last design, that is detailed design, we will clearly detailedly explain the product or part or the assembly drawings, so that by seeing those drawings the layman or the shop floor or the customer, everyone should understand what is the design and for which purpose we are creating, what are the dimensions of that product. So the engineering design process steps starts with the product definition and it ends with the detailed design. So in the earlier session itself we have seen the product definition. What do you mean by the product definition? It is like identification of the need of the customer and defining the problem statement. So we have seen in the last session clearly. Now in this session we will discuss all these three steps. That means conceptual design, embodiment and detail. So let's start with conceptual design. So as I already told you, the conceptual design is an early phase of the design process in which the broad outlines of the function and form of the designs are articulated. That means for which purpose we are doing this product, what is the function of that product. So like that we will do outline, what in which form it should be, what is the shape it should be, like that we will do. So in this conceptual design again it involves defining the problem, gathering the information, generating different concepts and evaluating those concepts. So the defining the problem involves we have to clearly define the problem statement. While defining the problem statement, sometimes we have to take the benchmarkings with respect to this. This is what I required. So that is called benchmarking. Product dissectioning, houses of quality, product design specifications, PDS, everything we have to consider while defining the problem. Then whatever problem we have defined, for that to understand we have to gather the information from the different sources like internet sources, from the patents, from the technical articles and by referring different journals. Like that we have to get the information from the different sources. And next one is the concept generation, creative methods and brainstorming session and the functional models, decomposition and systematic design methods. We have to use all these methods to generate different concepts for that particular design. And whatever concepts we have generated, we have to evaluate those concepts using these parameters. What are those parameters? Decision making criteria and selection criteria, Pugmart chart, decision matrix and AHP. All these parameters we have to use. So let's see one by one. The first one is the problem definition. I already told you the goal of this activity. The goal of this problem definition is to create a statement that describes what has to be accomplished to satisfy the needs of the customer, because always he is important in the design. Without him there is no design, because he is the one who required that design. If he says I don't require that design, means designing that product or that component is of no use. So it is as important to understand his requirement. So there is like, clearly we should understand the product design specifications. So what are the specifications of that product? A detailed listing we should understand while defining the problem. There is one tool called quality function deployment, which is a valuable tool for linking the customer needs with the design requirements. What the customer required and what the design requirements. So to link these two different criteria, we will be using quality function deployment tool to link these two requirements. What is the next one? We have to gather the information to understand the definition of the problem from the different sources. Those sources are like engineering professional societies like SAG, ISME, ISO, different journals we have to refer, intellectual properties, that means paper, patents, technical articles. Then we have to meet different customers or different persons to understand the problem. We have to visit the library to refer different textbooks, engineering handbooks and some text periodicals. From all these sources we have to gather the information corresponding to our problem definition. Once after gathering, we have to generate the different concepts. We have to collect the ideas, then generate the different concepts. Sometimes we have to reduce some ideas, sometimes we have to add some ideas, then finally we will be ending up with different concept. Once the concept is generated, the same concept has to be evaluated using some criteria. For example, go no go screening. For example, if you are designing slip gauges, so using this no gauge and no gauge or go gauge, using this criteria we can do the designing of the slip gauges. And another is the POC concepts, that means it is like some criteria. Okay, if material index is more than 1, then only we have to use this material. If material index value is 3.2, then only we have to use this material. So like that, some criteria conditions will be there to select that concept. So in a nutshell, what we are doing in the concept design, we are clearly understanding the definition of the problem and defining the problem and generating different concepts, and finally ending up with one concept that is evaluated. Okay, we are evaluating the concepts for different, using different resources and ending up with one concept. And what is the next step? The next step design is embodiment design. Here you can see the embodiment design is main engineering product design concept. It is because it is majorly involved economic criteria. It involves the product design specifications and economic criteria stage. That means almost all, or we can say 80 to 90% of the design requirements or customer requirements will be solved in this embodiment design. So what are the different steps involved in this embodiment design? First one is the product architecture, design configuration, parameter design. So let's discuss one by one. First one is the product architecture. So the product architecture majorly includes outlining and allocating the physical components or entities to the function of a product. For example, if I am working on the designing of the camera, so this is what my concept. That means I will do the concept, okay, my camera should look like this. It is the output of your concept design. And after this concept design, what we will do? We will do some outline and allocating the physical components. That physical components will call modules. So we will add the modules to this product. Then it will result into the product architecture, and those modules can fall under two categories. One is the modular architecture, another is the integral architecture. If you see here, the modular is nothing but is like different parts, and the integral is nothing but the assembly. So the product architecture can be of individual parts or it can be of an assembly. So the next step is design configuration. In the design configuration step, what we will do is we will assign the dimensions or sizes that should be the product should consist, and in the same design configuration process itself we will decide a preliminary selection of the material as well as which kind of manufacturing process we have to use and what are the dimensions and how to model it and what are the sizes of the different parts. Everything will be decided in this design configuration step. Once that is designed, so I am, let us say I told you already in the previous session the diameter of the shaft, let us say 10 mm. So for that 10 mm, is it okay or I have to change the dimension? Okay. In this parametric design, what we will do, we will assign different values for the design variables which will produce the best possible design considerations. That means we will do the parametric analysis on the different variables such that we will get at the end we will get the best design. So in this step also we will consider the dimensions and tolerances of the components. So in a recent time, the Ford company used the parametric design software to optimize the design of the Ford GT supercar. They have used this parametric design concept to develop and to optimize the Ford GT supercar. This is that car which they have used a parametric design to optimize its architecture and design. So what is the third step? The third step is the detailed design. So the detailed design, I already told you, the detailed design involves the part drawing or clear drawing or the detailed drawings of the individual parts. It also includes the dimensions and tolerances. That means it will mention whether this 100 mm is allowable or it can be 100 plus or minus 1, or what should be the roughness of this component, what is the maximum allowable dimension. Everything it will be clearly defined in the detailed design. Once this detailed design is done, then the same designs or drawings will be given to the customer or the shop floor person for the production of the components. So this is the third step which will end our design process. So here till now what we have seen, the detailed design we have discussed. So the three major design steps. What are the three design major steps? One is concept design, another is the embodiment design, and the final one is the detailed design. So these are the references and textbooks for further learning. Thank you.